Right, hi everyone. Today's day 4 in our unit on exponents and logs, and we're going to finally today learn what a logarithm is. So the idea is, if I had to solve this, 3 to the x equals 11, there's certainly no integer value that makes that happen. 3 squared is 9. 3 to the third is 27, so you might say, well, it's 3 to the 2 point something, 2.2 or 2.18 or whatever, but there's no integer that will make this true. We had a strategy on day 2 about getting like bases. I cannot get a like base because 11, there's no 3 to no exponent would make 11, so I can't get like bases here, but I need to solve this to find the exact decimal, 3 to what exact decimal would make 11. So mathematicians have come up with something called logarithms, log for short, that lets us solve exponent variables. So the most important thing that you're going to need to understand for today is how to switch from an exponent to a log and back. So if I have something like b raised up to the y equals x, that's the same as log base b of x equals y. So this is super important. Understanding this is the exponential form and this is the log form of the same thing. So we need to be comfortable switching from exponent to log and from log to exponent and knowing where items go. Many teachers call this the log roll. I don't know, because it's like b raised up to the y equals x. Or you can just think if b is the base here, it's the low number here. And then this exponent is always the answer. The exponent goes after the equals. Exponent is the answer. So if I wanted to switch this first one, this example that I just gave you up here, into log form, this would be log base 3 of 11 equals x. And now we can type this straight into the calculator and get an answer. But for now, I don't even care too much about the calculator. I just want you to get comfortable with switching from this to this and switching from this to this. So here's exponential form, and this is called logarithm form. And I'm going to give you a few examples of just switching back and forth next. All right, so if I have, again, let's say just 3 cubed equals 27. You know that to be a true fact, and then I want to switch it into log form. It would be log base 3 of 27 equals 3. So again, this low number here is low. It's written like a subscript. The part that's the exponent is after the equals. So it's 3 raised to the third equals 27. Of course, 5 squared equals 25. In log form, that would look like log base 5 of 25 equals 2. Let's do the reverse. 2 to the 5th equals 32. In log form, it would be log base 2 of 32 equals 5. Let's work the other way. What if I have log 464 equals 3? That is the same as writing 4 raised to the third power equals 64. I'll give you one more going that way. Let's go log 12 of 144. If I don't write what this equals, do you know? So the word log is just asking, the word log or logarithm means what exponent for 12 makes 144? 12 to what power makes 144? The answer here is 2. That's really all log means, and if I want to switch it from log back to exponential, it'll be 12 squared equals 144. I'm going to give you 2 more, but all variables. So suppose I have j to the L equals m. Take a minute and pause if you want to try it. The answer would be log j of m equals L. Because this high exponent is the answer, the j stays low. And then again, a reverse, if I do log x of b equals j, and they want you to switch it, the switch is x raised up to the j exponent equals b. All right, so that's one huge part of today. Being comfortable with log to exponent and exponent to log, working forward and working backward. And now we're going to solve some equations that are given to us in log form, and we're just going to switch them from log into exponential. So here's our example 1. Suppose they give you log x of 8 equals 3/4, and they ask you to find x. It looks very intimidating because this word log and all that's different, but all you're going to do is switch out of log form into exponential. So step 1 is switch to exponential form. So remember what we just practiced, our switch will be x raised to the 3/4 power equals 8. Those are equivalent. And now this is something that you learned on day 2. When I'm trying to solve this, I'm just going to raise both sides to the reciprocal. So I'll raise this to the 4/3. I'll raise this side also to the 4/3. This just drops out and gives me plain old x. 8 raised up to the 4/3, I believe, is 16. Remember, you can do this piecemeal. You can do a cube root of 8 and then raise it to the 4th. Or if you feel really confident with understanding this, you can just type it into the calc straight and get an answer. Okay, example 2. Example 2 will be log 2 of 64 equals x. I've put the x in a different spot, but the strategy is the same. I want it out of log form and into exponential form. So the log roll, or the log switch, will be 2 raised to the x power equals 64. It's going to be 2 to the x equals 64. We also had a strategy for solving this on day 3 as well, and that strategy was get a common base. So this is 2 up to the x. I would replace 64 with 2 to the 6th. Now that the 2's are alike, they drop out and x equals 6. All right, one more example, example 3. For example 3, I've got log base 9 of x equals 3/2. Want to switch out of log form into exponential, it's going to be 9 raised to the 3/2 power equals x. And in this example, I'm just ready to go. I just type this in the calculator, or we can do it in our head probably. Square root of 9 is 3. 3 to the 3rd power is 27. My answer here is 27. So I just gave you 3 different examples of log equations, and in all 3 of them, the x was in a different spot, right? In this example, the x was here. In example 2, the x was over here. In example 1, the x was down here in the base. It did not matter where the x was. When you switched it from log form to exponential, then you'll be able to pick a strategy. Oh, if the x is down low in the base, I did the reciprocal thing. When the x was up high, I got common bases. If the x ended up over here, I didn't have to do anything but just type straight into the calculator. That is essentially it for today. I'm going to show you maybe 1 or 2 more, and that'll be it. So we'll call this, I guess, example 4. Let's do log 4 of x equals -3. Again, what you want to feel comfortable with and confident with is your ability to switch and know where the pieces go. It's going to be 4 raised up to the -3 power equals x. This part that's after the answer is always the exponent. And then again, because x ended up here, this can go right into the calculator or into our head. The negative is going to make it 1 over 4 cubed. This is going to be 1 over 64. And that's my value for x. I think that we're okay. Actually, I've got one more for you because I did forget that I gave you a sheet to do, so I want to make sure that the video is not too long so you can do your practice. So this will be our last example. Let's call it example 5. Log 4, 8 equals x. All right, the switch from log to exponential will be 4 raised to the x equals 8. It feels like the answer should just be 2 or something, but no, because remember this is like an exponent. 4 squared wouldn't be 8. So this one is from day 2 where we need to get a common base. So we're going to replace the 4 just with 2 squared. I'm going to replace the 8 with 2 to the 3rd power. These distribute because of that double exponent deal. And then you drop out the bases and just set the exponents equal to each other. My answer here is 3/2. By the way, all of these would be able to be checked in the calculator. If you went back to this very original and did log 4, 8, it should just give you 3/2 in the calculator. But at this point, I'm staying away from the calculator because you need to understand how to switch it and how to solve it. And then when you come into class, we'll talk about how the calculator would be able to support you with that. All right, you have a sheet to do that has a whole front side with a bunch of practice switching between the forms, and on the back side, some solving practice. I wish you luck, good luck, and sign up for AA right away if you need some help. Thanks, we'll see you tomorrow.